Hello to our televiewers and to all the grade 7 students of Catbalogan City. Welcome to another episode of School on Air program brought to you by the Department of Education through the Schools Division of Catbalogan. I am your teacher for this session, Teacher Tin, to discuss with you Module 2 of Grade 7 Mathematics on the topic Problem Solving Involving Sets. But before we proceed with our topic, let us first have a recap of the important concepts in Module 1. Let's try to recall them through this review. Number 1. It is a well-defined collection of distinct objects. Answer: set. Number 2. It is the set of all possible elements of any set. Answer: universal set. Number 3. A set with no element. Answer: null set. Number 4. It is a diagram that makes use of geometric shapes to show relationships between sets. Answer: Venn diagram. Number 5. These are sets with a continuous number of elements, often denoted by 3 dots called ellipses at the beginning or end of the list. Answer: infinite. Number 6. This is a method describing a set by listing each element of the set inside the symbol. Answer: raster or listing method. Number 7. The set of all elements in the universal set that is not in set A is called the blank of set A. Answer: yes, complement. Number 8. The set containing all the elements of set A or set B or both sets is called the blank of set A and set B. Answer: it's union. Number 9. The set containing all the elements that are common to both set A and set B is called the blank of set A and set B. Answer: correct, intersection. Last, number 10. The set of elements that belongs to set A but not in set B is called the blank of sets A and B. Answer: yes, difference. Congratulations! If you got it perfect, you truly are a set master. I think you are now ready for another fun-filled mathematics class. We are now in Module 2 with the topic Solving Problems Involving Sets. This module, aided by this TV program, will help you master your skills in solving mathematical problems involving sets. Specifically, after going through this module, you are expected to solve problems involving sets using Venn diagram and apply set operations to solve a variety of word problems. Now go to page 5 of this module. Problem solving involving sets requires a systematic approach to develop confusion and mixing up of your thought. Since elementary, you have been applying certain problem-solving techniques, either your teacher taught you or you devised your own method. Hence, I'd like to remind you that you have the freedom to perform problem-solving mechanism that best work for you as long as your method makes sense. The solution is organized and that the answer is correct, okay? One problem-solving technique is by using Venn diagram. The Venn diagram is a principal way of showing sets diagrammatically. This method consists primarily of entering the elements of a set into a shapes usually oval or oblong. It can be used to solve word problems involving union and intersection, complement of a set, and difference of two sets. In solving set operations using the Venn diagram, the following are the steps to be followed. Step 1. Determine what is given and what are being asked. Step 2. Illustrate using the Venn diagram. Step 3. Determine what operations to be used. Step 4. Use the operations. And lastly, Step 5. Answer the questions being asked. Let's discuss first example number 1 found in page 5. The problem states, let A and B be two finite sets such that n of A is 20, n of B is 28, and n of A union B is 36. Find n of A intersection B. Note, n of a set denotes the cardinality of a set, meaning set A has 20 elements, set B has 28 elements, and 36 elements are in either A or B. And we need to find the cardinality of A intersection B, or the number of elements in A intersection B. Step 1. The given are stated there. The n of A is 20, n of B is 28, and n of A union B is 36. And we need to find the cardinality of A intersection B, or the common elements of sets A and B. Do you follow? The next step is very crucial, the construction of the Venn diagram. One wrong information will affect all the rest, thus your answer. The given gives you the idea as to how many ovals will be assigned to respective sets. Since you are asked to find the intersection, it is likely that the two ovals overlap each other, thereby making 3 sections. You can see in step 2 that the diagram illustrates the universal set U, which is the rectangle. Inside is the diagram, the left oval for set A, and the right for set B. The middle section, or to which the two ovals intersect, is what we need to find. The third step is to determine what operation to use. As you can see in the module, the solution is a bit complicated considering your knowledge in algebra. So, we will perform our solution using your knowledge about set operations but still come up with the answer. Now go back to the Venn diagram. Now let's name the 3 sections as 1, 2, and 3 respectively. The left as 1, the middle as 2, and the right as 3. We know that the cardinality of set A union B is 36, or the cardinality of section 1 plus cardinality of section 2 plus the cardinality of section 3 equal to 36. Do you follow?
Oh, yes!
Out of 36, set A has a cardinality of 20. By the way, which sections compose set A? Yes, very good. 1 and 2. Meaning, the cardinality in 1 plus the cardinality in 2 is equal to 20, right?
Oh, yes!
Now, let us shade up the oval for set A, the whole of set A, or sections 1 and 2. What section or part is left unshaded? Yes, the right section or section 3, where the name for set B is located. Correct? Now, let's perform the operation using our knowledge in arithmetic. What is sections 1 plus 2 plus 3 equal to, as illustrated in the diagram? Yes, 36. But we know section 1 plus 2, correct?
Oh, yes!
What is section 1 plus 2 equal to? Yes, 20, the cardinality of set A. If sections 1 plus 2 is 20, how much more is needed so that 20 plus section 3 is equal to 36? Yes, very good, 16. So therefore, section 3 is equal to 16. Can you write it there? Now, we know section 3 already, it's 16. But we do not know specifically how much is 1 and 2 individually. We only know that they sum up to 20. Focus your attention now to set B this time. What sections compose set B? Yes, sections 2 and 3. Again, how much is set B? 28, correct. That goes to show that sections 2 plus 3 is 28. Since section 3 is 16, then we have section 2 plus 16 is 28. And what is that number when added to 16 gives 28? Correct, 12. Therefore, section 2 equal to 12 plus section 3 equal to 16 is equal to set B equal to 28. And lastly, finding section 1 is very easy. Now, owing addition property. Section 1 plus 12 for section 2 plus 16 for section 3 equal to 36. A number plus 12 plus 16 that gives 36 is 8. So we have 8 plus 12 plus 16 equal to 36. Now, it's time to answer the question. Find the cardinality of A intersection B. As illustrated, A intersection B is just the middle section or section 2 which is equal to 12. Therefore, the cardinality of A intersection B is 12. How do you find this method? Is it easy for you? As I have said, you have the free will. You can use any method that you are comfortable with. In fact, in mathematics, there is no single process to which an answer is derived. If you fully comprehend the one suggested in the module, then that's a good point. Now this time, let us discuss example number 2. An example of a real-life problem that can be mathematically solved using the approach we know about set. The problem goes, in a junior high school, 200 students were randomly selected. 140 liked tea, 120 liked coffee, and 80 liked both tea and coffee. A. How many students like only tea? B. How many students liked only coffee? C. How many students liked neither tea nor coffee? Help me analyze the problem first. 200 students were asked about which drink they do like, coffee or tea. You can see from the given, 200 students were asked. 140 liked tea, 120 liked coffee, and 80 liked both. Then, we need to find how many liked tea only, coffee only, and who liked neither of the two. Let's proceed to how the diagram was constructed first. As you can see, the same example we had, the universal set, 2 overlapping ovals assigned to set name T for tea at the left and C for coffee at the right. But notice the letter X below. What do you think is that for? Yes, correct. That stands for the set of students who neither like coffee nor tea, or as for set concept, the complement of T union C. Do you follow?
Yes!
Focus on the Venn diagram. You see, 80 is written in the middle section, represent the students who like both coffee and tea. In step 3, you can see the left section is named T for tea only, and the right section as C for coffee only. First, T is obtained from the relation that T, which is section 1 plus section 2, which is equal to 80, is equal to 140. That's T plus 80 equals 140. And what is the number that will complete 80 to become 140? Yes, 60. That's why T is equal to 60. Same thing was done to obtain C, giving C equals 40. Then we supply the values for T and C in the diagram respectively. So we have 60 to the left, 80 at the middle, and 40 at the right. But why is the value of x 20? Look at solution 3 of the third step. If we get the sum of 60, 80, and 40, or the union of T and C, this cardinality subtract from the cardinality of the universal set is the cardinality of the complement of T union C. Simply, 200 minus the sum 60 plus 80 plus 40, we get 20. Thus, x is equal to 20. Are we clear in this part? Now that we have supplied the required values of the sets, let us now answer what we are asked to find. Letter A. How many students liked only tea? 60 students. How many students liked only coffee? 40 students. Letter C. How many students liked neither tea nor coffee? 20 students. In the previous two examples, we dealt with problems involving two ovals in the Venn diagram. This time, let us have an example that requires three ovals in the Venn diagram. Go to example 2 of page 10. The problem. A group of 50 students went for a tour in South Cotabato province. Out of 50 students, 24 joined the trip in Lake Cebu for a zipline experience. 18 went to the flower farm in Tupi. 20 went to Siok Falls in Coronadal City. 12 joined the trip to Lake Cebu and Tupi. 15 went to Tupi and Siok Falls. And 11 made a trip to Lake Cebu and Siok Falls. And 10 visited the 3 tourist spots. Then we are asked to find A. How many of the students went to Lake Cebu only? Letter B. How many of the students went to Tupi only? Letter C. How many joined the Siok trip in Coronadal City only? Letter D. How many did not go to any of the tourist spots? In this step 2, you can see the initials of the 3 destinations. L for Lake Cebu, K for Siok Falls in Coronadal City, and T for Tupi. 2 or 3 letter combinations that you see in the Venn diagram denotes that more than one destination is toured by certain number of students. Now, the Venn diagram shows 3 ovals overlapping each other. Each represent L for Lake Cebu, K for Coronadal City's Siok Falls, and T for Tupi. On the other hand, N stands for number of students who did not see any of the 3 tourist spots. So how many sections are formed from the 3 overlapping ovals? Still in page 11. Let's count. 1, 2, 3, 4, 5, 6, and 7. So see the middlemost section named LKT. That's for the number of students who visited all the 3 places and so on. You can see in step 3 how the number in each section with the corresponding name were determined based on the given. Let's discuss each. First, LKT is 10 from the given, meaning 10 students were able to visit the 3 tourist spots. TK, LT, and LK is 4 students who went to only 2 tourist places respectively. It follows that TK is 15 minus 10, LT is 12 minus 10, and LK is 11 minus 10. Discount the number for LKT from being redundantly included, thus TK is equal to 5, LT is equal to 2, and LK is 1. What about the number of students who toured to one spot only? That number stands for L, K, and T in the Venn diagram, right? Let's have the set for those who went to Lake Cebu. This 24 accounts for the students who went to the lake regardless if they have visited the other two places. The same idea holds true to 18 students who visited Tupi and 20 students who went to Coronadal City. Their other destinations are irrespective. Back to the module. You can see in solution 5 of step 3, L is determined by adding the numbers of 2 or 3 visited places. That's LKT plus LK plus LT. You notice that they all have L's. Nice clue, you think. Thus, we have 10 plus 1 plus 2 equal to 13. Then subtract the sum from 24. 24 minus 13, so we have L equals 11. Now, do the same process to determine K and T. Here, K is 20 minus the sum of LKT, LK, and TK. Clue again, all with K's. That's 20 minus 10 plus 1 plus 5. 20 minus 16 equal to 4. Thus, K equal to 4. For T, that's 18 minus LKT plus TK plus LT. All with T's, right? So that's 18 minus 10 plus 5 plus 2, or 18 minus 17, and that's equal to 1. Therefore, we have 11 who went to Lake Cebu only, 4 who visited to the Siku Falls in Coronadal City only, and 1 visited Tupi only. All the rest visited 2 or 3 places. We can now write the values in each section to complete our Venn diagram. Now, this time, the value of N. The number of students who joined the tour in South Cotabato Province but did not visit any of the 3 mentioned tourist spots. Well, to get N, simply determine L union K union T, or get the sum of all entries in the Venn diagram. That's LKT plus TK plus LT plus LK plus L plus K plus T, or 10 plus 5 plus 2 plus 1 plus 11 plus 4 plus 1 equal to 34. Same to the previous example. Subtract this from the cardinality of universal set. The number of students who joined the trip, that's 50 minus 34 equal to 16. N is therefore equal to 16. Lastly, answer the questions being asked. Letter A. How many of the students went to Lake Cebu only? 11 students. Letter B. How many of the students went to Tupi only? Answer, 1 student. Letter C. How many joined the Siok trip in Coronadal City only? 4 students. Letter D. How many did not go to any of the tourist spots? Answer, 16 students. Finally, we are done. However, I want you to test yourself how much you have learned from this topic, solving problems involving sets. So in page 14 of the module, under the heading, What's More, problem number 2, I will give you 1 minute to read the problem, understand the diagram, and answer the following questions. And now let us check your answer. Letter A. How many students ride in a car, tricycle, and a motorcycle in going to school? Answer. 15 students ride in a car, tricycle, and motorcycle. Letter B. How many students ride both in a car and a tricycle? Answer. 34 students ride in both car and tricycle. Letter C. How many students ride both in a car and the motorcycle? Answer. 35 students ride both in car and in motorcycle. Letter D. How many students ride both in a tricycle and a motorcycle? Answer. 32 students ride both in tricycle and in motorcycle. Letter E. How many students go to school in a car only, tricycle only, in the motorcycle only, walking? Answer. 55 students ride in a car only, 67 students ride in motorcycle only, 76 students ride in tricycle only, 100 students preferred walking. Letter F. How many grade 7 students of Coronadal National Comprehensive High School are there in all? Answer. There are 269 students. That's it for our session. I hope that this TV program helped you a lot to understand your lesson since you are studying the module on your own. If you still have questions, clarifications, or confusions, you may seek the help of anyone you live with at home to explain to you the hazy parts. If there is none, it pays to read and reread the module, go over the examples several times. That's an excellent studying technique that really works, okay? There you have it, grade 7 students. We have accomplished once again another episode of School on Air Mathematics Instruction on the topic Solving Problems Involving Sets. It has been a wonderful time being with you, our dear learners. Join me again in our next episode for a new learning opportunity where studying math is just so fun and easy. I am your teacher, Ma'am Tin, saying, we heal as one, we learn as one through Bayanihan.